Hello and welcome to the first episode on the Cow-munication channel. Today I'm pleased to have Geneva Graef, a PhD student from Tom Overton's lab in Cornell University, give us a brief presentation on her research, which has been milk fevers. Milk fevers will affect 5% of animals globally, and around 25 to 45% of animals in your herd will be affected in a subclinical way. On a 100 cow herd, that's $5,000 per year. Stay tuned to see how we can make that better.
Hello everyone and welcome. Hello Geneva.
Hello.
It's a pleasure to be able to speak to you today, and we just wanted to get together basically to discuss some of the work that we've been doing with our key account here in National Dairy Farm in the United Arab Emirates. Some of you will be familiar with that, the global mineral success story that was launched by Alltech. And we're very lucky, very fortunate to have Geneva here, who is a PhD student from Tom Overton's lab, specializing in calcium absorption and hypocalcemia. And Geneva also has a very interesting background, which I hope she will talk a little bit more about in terms of her background in infectious diseases. So without further ado, Geneva, if you'd just like to give a brief introduction to yourself and kind of what was your background and then what you're currently doing.
Sure. So hello again. My name's Geneva. I'm actually really excited to be here. This will be fun. I love having these kinds of conversations. Kind of lower key and just really applied stuff. So this is truly a pleasure. Thank you. Yes, as Paul mentioned, I am a PhD student for Tom Overton at Cornell. I'm in my fourth year. Hopefully finishing up in the next year and a half here. Before working with Tom and looking at transition cows and hypocalcemia, I actually had kind of a rather unique, unorthodox path to get here. I'm originally from Honolulu, Hawaii. I did my undergraduate at University of Hawaii at Manoa. A lot of that was looking at beef cattle. A lot of my background is looking at shipping stress and disease management. As an undergraduate, I also dabbled a little bit. I did some work in Micronesia looking at roaming dogs, how that relates to childhood health, and that sort of set me on this path of research, what I really loved. Worked at Washington State University and then Virginia Tech for a time. Most of that was looking at infectious diseases, particularly Cryptosporidium parvum, which, as I'm sure everyone listening to this knows, is quite prevalent on dairy farms and calves. It's a big deal. It also happens to be the second leading cause of diarrheal illness in children in low middle income countries under 5. So a lot of my work then was drug development. And then I made the leap over to nutrition because I think that there are some really strong links and connections. There's the call to prayer. But yeah, I think it's really important when I look at my research it's important to get into these nitty-gritty details and mechanisms and things like that to be able to zoom back out and see the bigger picture and how they fit together, because this work doesn't exist in silos, right? The world is happening all around us all the time simultaneously. So it's good to look at it that way.
Very cool, Geneva. Thanks. And just that's an interesting point on the Cryptosporidium. Have you anything else further to add from your studies on Cryptosporidium and vaccine development? What's your kind of take on that in general? Or
so we didn't do any vaccine development. We did chemotherapeutics, so just treatment of disease, no prevention work. I guess my area for that was specifically working with calves and cattle. And we teamed up with human physicians, veterinarians, obviously pharmaceutical companies, the Bill and Melinda Gates Foundation. And I think I would say that when it comes to doing that type of work, particularly when you're looking at a disease like crypto, what I found really valuable is looking at it's this thing of not just burrowing down into just one lane, but stepping back and looking at the bigger picture. So one of the key pieces to our research that I think was really valuable is that when I look at transmission studies, but from cow to cow, I'm also keeping in the back of my head transmission of cow to person, person back to cow. When we do come up with a chemotherapeutic and looking at clinical trials, what is the longer term goals in terms of rollout? How are we going to make this really successful? Because treating the actual bug is like one piece of the entire puzzle, right? You need to have all kinds of government support, regulatory support, and then you need buy-in on the other end from your customer. And so how do you answer all of these questions within a scientific research trial? I don't know, I kind of got a little tangential there, but I hope that was answering your question.
Not at all, not at all. And that's I kind of nearly prefer when we go off. I'm pretty similar myself when I start talking about one area, and then all of the other pieces that come into play kind of enters into the discussion as well. So it's a little bit challenging. So great, Geneva. I think if you don't mind, you can maybe share your presentation and then kind of run through some of the work that you've been doing. And then if I have any questions, I'll try and maybe not interrupt you too abruptly, but yeah, we can see how it goes from there.
No, please interrupt me. I'm not sure I can actually see you while I'm sharing my screen. So just go ahead and holler at me if I say something that makes you think. Oh, no, I can. Okay. All right. So this project that I'm going to present is actually the first one that I did in my PhD. I believe my last day at my job with Virginia Tech was a Friday, and my first day with Tom was Saturday morning at 8, and I spent 6 hours learning all of the spreadsheets and everything that needed to happen. So yeah, this is my first real baby, for lack of a better word here. And I took this project through a global pandemic. I don't know if you've heard of COVID-19, but we had numerous challenges. But again, I wouldn't exchange the experience for the world. I learned a tremendous amount in terms of both this question and just the study as a whole, and how to kind of move this forward in crises. But the title of the project is The Effects of Varying Levels of DCAD and Dietary Calcium Supplementation in the Prepartum Period on Cow Health and Production. I'm sure everyone listening to this is well aware of hypocalcemia, if not at least milk fever. That's great. I like to kind of set the stage here so that we're all on the same wavelength as we talk about this. Of course, hypocalcemia is referring to depletion of circulating calcium in the blood below normal levels. Milk fever is a clinical representation of that hypocalcemia. That's when you see that down cow, the cold extremities, and that has been well described in the literature, very well observed on the farm. Subclinical hypocalcemia is when we know that those circulating calcium levels are low, but we don't necessarily see some of those clinical signs. Again, that's something that's been pretty well described. We look at herd prevalence for milk fever is something below 5% because we've gotten a really nice control over it through some nutritional strategies we'll talk about. Subclinical hypocalcemia we tend to describe as prevalent in about 25 to 40% of cows in a herd. That if you're thinking, wow, that's a big range, it's because it is. And recently we've got a lot more work now that's piecing that apart and splitting that hair, which I really don't even think is a hair, right? I think that there is a lot more granularity to the subclinical story than we've known in the past. And I'm going to refer a lot to Jess McCart and Raphael Nevis's work because they've contributed, Jess McCart in particular, quite a bit to this story and splitting subclinical hypocalcemia into 3 different groups. And we'll dive into that some more, but there's transiently hypocalcemic, delayed, and persistent. And really it's those delayed and persistent groups that we're really concerned about. We know again that this depletion in calcium stores really occurs during calving, and that transition period is when we're concerned about it. If you think about it, the cow is this incredible piece of physiology that has all kinds of mechanisms to manage calcium homeostasis. But at that transition period, her demands and calcium requirements just go up like that exponentially. We're looking at a normal maintenance requirement of about 20 grams a day. And then just for lactation, we're 2-3-fold from that at least. And we need, and lactation really is only part of the puzzle. That's a big demand, but we also need calcium for partition in and of itself. We're combating some decreases in dry matter intake in that close-up period just naturally. So what can we do to interrupt or interject in this already very efficient mechanism to set her up for the best success? So I've alluded to this mechanism, and bear with me on this little schematic. If you all already know what's going on, then great, you're ahead of me, but we're going to walk through it quickly. The parathyroid gland in the cow is what's responsible for holding those calcium sensing cells. When they start to detect low calcium in the blood, the parathyroid responds by releasing PTH. PTH really acts at the level of the bone, particularly, and signals for increased calcium resorption. This can take minutes to days, but her efficiency and her ability to respond at this level is going to be really key to this story. We know that PTH also signals at the level of the kidney. Certainly, there's some kidney excretion and reabsorption that's occurring, and a little bit of it is working at that level, saying, hey, stop dumping calcium. We actually kind of need that. But really, it's also activating vitamin D to that dihydroxy form, which the vitamin D is then going to go over to the gastrointestinal tract and say, hey, we need to actually start absorbing some of the calcium that we have available here, and make it available to the cow. And that takes a little bit more time, which is why I say the bone resorption is really where we want to maximize some of that. So I think we're pretty aware of the dietary cation anion balance, and manipulation of that is a really common strategy, particularly in the U.S. is what I'll speak to. That's where most of my work is based on. But I've seen it happen. I've seen it very efficiently used here in National Dairy. So well done, Paul. Looks fantastic. And the DCAD manipulation is a great way to manage this. You're adding anionic supplements you can add anionic supplements, and restrict cations. You can do both. And really what this does is puts the cow into a state of a compensated metabolic acidosis. Compensated is an important word here. You don't want to go too extreme, but having her in a bit of an acidotic state can be really beneficial to signaling sensitivity. So this will reduce your incidence of hypocalcemia. So if we go back to our schematic and kind of interject here by decreasing the DCAD, it increases tissue sensitivity to PTH, which allows the bone to more efficiently free the calcium, increases the activation of that vitamin D, and really helps theoretically improve some of that absorption at the level of the gastrointestinal tract. So that's what's happening when we're manipulating DCAD. We argue that lower levels of DCAD really have greater effects on improving health and production in the cow. It does reduce some prepartum dry matter intake, and then dietary supplementation may actually prevent some of these dry matter intake drops. If you're familiar with Glossen's work, published in about 2020, there were still dry matter intake decreases with a more acidified diet, but she saw perhaps I think it was a tendency of an effect of that higher calcium. I think she was at about a 2%, actually increased the dry matter intake some. There's also a discussion about calcium restriction. If you've heard of zeolite, some of the calcium binders, things like that. That is a really interesting discussion on, okay, so if we can restrict enough calcium, maybe that'll kickstart some of the mechanism, because those calcium sensing cells will be like, oh, there's a depletion, we've gotten below maintenance, and actually kind of kickstart some of that as well. Doing calcium restriction alone is really difficult in an applied setting. Graef and Kozowski, I hope I'm saying his name correctly, in 2018 showed that you need to get below 0.4% calcium in order to drop maintenance requirements below that 20 grams per day. And that is actually quite challenging to do. But we do think that there's something to this story of this lower DCAD to maintain that compensated metabolic acidosis with any kind of addition of calcium. And we are big proponents of higher levels of calcium. There have been meta-analyses showing that lower DCAD can affect health outcomes in metritis, retained placenta, milk fever, of course, overall. We know that Paris cows actually produced more milk, more fat-corrected milk, fat and protein, so components. And then addition of dietary calcium supplementation in their meta-analysis was shown to increase the risk of milk fever. Lean et al. In 2019 similarly found that there were lower levels of DCAD. They improved health outcomes, again, particularly for Paris cows. But in this meta-analysis, there was no recommendation for calcium level. Given this mixed with some of the other research, I talked about Glossen's work, Amundson's work, there's really not a great single answer to this question of what is optimal DCAD, what is optimal level of dietary calcium fed prepartum, and is there an interaction of an effect of dietary calcium supplementation in DCAD? So those were the questions we really sought to answer, and that was the birth of these objectives, right? Compare the effects of two prepartum DCAD strategy in two levels of dietary calcium and their interactions on the parameters of calcium metabolism and milk performance. Our hypothesis is that cows fed a lower DCAD determined by urine pH, which is a really important point we can come back to if we'd like, and a higher dietary calcium would have an improved effect on calcium status and performance. So jumping right into our study in the background, this is a beautiful picture of our cows. The study was conducted in Thai stalls, so this is out at the Cornell University Research Farm. But we enrolled a lot of cows, especially with the pandemic, but I have 98 Holstein cows, multi-pairs Holstein cows, so of second lactation or greater, enrolled at about 32 to 39 days prior to expected partition, all fed the same far-off diet, high straw, controlled energy. And then at about 26 days prior to expected partition, they were randomly assigned one of 4 treatments. We had a high versus a low calcium. So you can see in the schematic, it's a 1.5% versus a 0.7%. And then we had a full versus part DCAD. And full was defined as a DCAD strategy targeting a urine pH of 5.5 to 6, and the part was targeting a 6.5 to 7. When cows calved, they all went on the same fresh diet and stayed on that diet until 63 days in milk. I just tried to combine all of our sampling parameters into one slide just because there was a lot that went on, but we did body weights, body condition scores weekly, dry matter intakes daily. Looked at blood mineral concentrations, obviously monitored urine pH and ammonium, particularly in that prepartum period. We'll talk more about ammonium too. Urine mineral excretion, colostrum weight and IgG. And then daily milk weights and weekly components were evaluated.
So this is Geneva. Just to jump in there, this is a really, I mean, what you mentioned, 93 cows. Is that what you said? So this is quite
98, yeah.
98 cows. This is an extensive study, especially in an applied research setting. Normally,
Yeah.
you see a lot of studies out there, and it's kind of 20 cows. They're kind of shouting from the rooftops when they have a study with 20 cows. So congratulations. It must have been a lot of work. I didn't realize there was actually that many cows. So congratulations.
Tremendous. So 98 cows are the cows that completed it. I'm scared to admit to you how many cows we actually enrolled because we had to do it through the pandemic. And so that meant we had to shut down, which meant we lost some, didn't lose them, but we had to take them off of the study because we couldn't go out there and sample, right? So I think I actually have something like 180 cows that came through my study, and I could not have done this without, I had research techs, I had undergraduate students, I had interns. It was just a tremendous effort on our research team's part, and you're correct. Transition cow studies are extremely difficult to do. I don't care if you're doing 10 cows or if you're doing 100 cows. But yeah, you're right. Having a sample size that large and trying to manage all these different sample collections was truly I commend my team. They did amazing. It's not a one-woman show, that's for sure. So first, I guess I tried to bring it down to one side. I guess I left these slides in. Basically, urine was collected 3 times a week just to monitor. We also evaluated urine ammonium. I think we only actually had to adjust once at the very, very beginning of the study. But other than that, they've stayed really consistent in that range, and I'll show you the results of that later. We did prepartum samples weekly, actually quite similar to what I'm doing on this trial at National Dairy Now, in order to capture that -1 week sample. For this study, we did daily in the last week prior to expected partition, because we were trying to really collect within that tight time points around calving. We looked at ionized calcium, and then total calcium, phosphorus, and magnesium. Postpartum, we did 4 samples within 2 days, and then analyzed all of those for ionized calcium, total calcium, phosphorus, and magnesium. And that is, a lot of that is based off of previous work within our lab, and then of course Jess McCart's work. Milk yields, this is our milk sampling station. This is actually beneath the milking parlor. And this is completely set up, so we have a whole team that runs up and down the stairs. So quads for days when we run studies like this. Colostrum was also weighed and IgG evaluated. Again, we took milk weights till 60 days in milk, and then weekly samples were taken for milk composition. This is the fun part. I know everyone loves to talk about the statistical analysis. Data underwent ANOVA using a PROC mix with fixed effects for calcium level, DCAD level, time, parity, and interactions with a random effective cow nested within calcium and DCAD level. Repeated measures included a statement for time, and then covariate, were included in the model when pretreatments were available. All right, now for the fun stuff, the results and some of the discussion. I threw up the ingredient composition here. There's going to be a QR code at the end, which should still be active. So if I'm only going to point out here, we used Animate as our anionic supplement, filler for those partial DCAD cows. That was the higher urine pH, and then calcium carbonate here, which you can see there. Essentially, there's more calcium carbonate in those higher calcium fed cows than the lower calcium. If you really want to dig into the nitty gritties and reach out and contact me with questions or anything like that, please do. Again, the QR code at the end will give you access to all of this data. This is our analyzed diet composition. I just included the four prepartum treatments. Again, I don't know, can you see my mouse? Okay, so these first 2 are high calcium, second 2 are lower calcium. Then we have full part. So really, I just want to point out that we hit our targets really nicely here for calcium and DCAD. Everything else is very similar within it. We looked at, this is the milliequivalents, but I'm going to show you the urine pH to prove that we hit our targets really well. And then of course we have about a 1.5% calcium where we want it, and about a 0.7 where we expect it. All right, so here we have a table looking at the dry matter intakes, body weights, body weight changes, and body condition scores by treatment, and then p-values. So it's all going to be arranged in the same order, just so it's a little easier to see. We had an effect of calcium on body weight change in the prepartum period, such as those cows fed the high calcium diet gained a little bit more weight than those fed the low calcium. I want to point out here, I was a little surprised by this. There was also an effect on body weight change, but in the postpartum period by DCAD, such that those cows fed that full DCAD actually lost less weight postpartum. And then a tendency of an effect of calcium on dry matter intake postpartum. And I'm going to believe I split this out. Yeah. So actually, I'll just go to the next slide and we can talk about it. I broke out the graph a little differently. So I just looked at main effects of high and low calcium, so we can see better this tendency of that effect, that high calcium meant greater dry matter intakes for those cows postpartum. And then this is the figure looking at the intakes from weeks 1 through 9. This will be consistent through the presentation. The black lines are all high calcium fed cows, 1.5%. Red lines are lower calcium, 0.7. And then dotted lines are always going to be your full DCAD cows. So you can see through weeks 1 through 9 with a little bopping, pretty consistently ate more, except for maybe around week 8. I'm not sure what happened, but yeah. Here I told you, I promised I'd come back to that urine pH. We hit our targets nicely. Full was targeting a 5.5 to 6, which again we did. Part was targeting a 6.5 to 7, which we did. Urine ammonium, this was really interesting to me. Urine ammonium, we saw that those cows fed that full DCAD excreted more urine ammonium than those cows fed part, and then saw this tendency of an effect of calcium, which makes sense to me. It's a cation being added in, such that those cows fed, I guess I don't have a breakdown here, but those cows fed the higher calcium diet actually excreted slightly less ammonium than those cows fed the part, which again makes perfect sense, and you can really see it split out nicely here in this graph. Again, the low calcium fed cows split off really distinctly here from those higher calcium fed cows. But of course, DCAD, really high ammonium excretion prepartum. Again, a little getting juicier as we go along with our data here. So now we're going to talk about blood minerals. I have ionized calcium, which is just the active free calcium. Total calcium, that's all bound and unbound calcium, and then phosphorus and magnesium in the prepartum and postpartum period, organized by treatment. We saw an effective DCAD, such that those cows fed that full DCAD diet had lower total calcium in the prepartum period. Cows fed DCAD, oh my goodness, tripping on my words here. There was also the tendency of an effect in the postpartum period on phosphorus, such that those cows fed the full DCAD had higher circulating phosphorus, concentrations of phosphorus. And then this calcium by DCAD by parity effect, such that those cows fed, and I'm going to break this down, I think, later. Okay, here we go. Such that those cows fed the high calcium diet. Multiparous cows fed the high calcium diet, had lower levels of ionized calcium. Did I say that correctly? Fed the high calcium diet, had lower levels of ionized calcium. Whew. And then those cows fed the full DCAD had a tendency to have a higher ionized calcium, which again is understandable, I think. And then this is the breakdown of days one, basically the first 48 hours, we have a 0.5, day 1, a 1.5, and a 2. And the lines are organized the same way in the figure. So this I thought was pretty interesting, that we saw more of an effect, particularly when you showed the interaction by parity. Typically, when we talk about these treatments with multiparous cows, we're looking at nulliparous versus multiparous. We don't typically describe second lactation versus greater than second lactation, but we did see a difference here. I don't like really talking about minerals by themselves. They kind of with the same tangent I've been going on. Maybe that's the theme, is that it all fits in a bigger picture. So when we talk about mineral status of the cow, we should also be considering, okay, what was her colostrum? What was her milk yield too? We saw this really interesting effect on colostrum weight. So those cows fed that full DCAD, particularly the full DCAD with a high calcium, produced more colostrum than did the part DCAD counterparts. This, I have looked in the literature, to be perfectly honest, and I have not seen other examples of this. I think a lot more work needs to be done here, because clearly the effect demonstrated here was tremendous numerically. I'm not sure I have a great answer as to why yet. I've been working on it. If anyone has any ideas, please call me. I didn't see a tremendous difference in terms of colostrum quality. Colostrum IgG and yield were comparable between groups, but yeah, this colostrum weight question, again, I don't see this in the literature. I haven't found a good answer for it. So yeah, I'm open to discussing it further if anyone has any brilliant suggestions for me. Excuse me. Milk yield and composition. We didn't see a tremendous amount of differences in terms of composition of the milk, fat, protein, lactose, energy-corrected milk, all very comparable between groups. We did see this tendency of an effect of treatment with time, such that those cows fed that 1.5% calcium full DCAD had or produced more milk. And I have a figure here to kind of illustrate that. This is obviously looking at it through weeks 1 through 9, and I see just visually, you can see week 2 that high calcium full DCAD group splits out from the herd. Excuse the pun. But yeah, they produce a little bit more milk, and if we look at our conclusions here, we talked about from a cow mineral perspective, mineral status perspective, those cows fed that 1.5% full numerically had improved milk yields, but maybe had a little bit lower ionized calcium, total calcium. So I think that's why it's important to interpret some of this all together as part of a more complete story, instead of just looking at one or the other. Overall, feeding that higher calcium diet in conjunction with a more negative DCAD, and you need to measure that DCAD looking at urine pH, reduced ionized calcium levels of the cows postpartum, but it numerically improved the production. So again, telling kind of the full story there. So that's the end of the presentation for this study. The photo behind here is a picture of Kirk. Future works, we're really interested in continuing to explore this distinction of these subclinical hypocalcemic groups, especially in conjunction with inflammatory markers and how that works in transition. But yeah, that's what I've got for you.
Excellent. Thank you, Geneva. So there's some things that I'd just like to delve into a little bit further. Were you looking at anything else there in terms of metabolic disorders, metritis or retained fetal membranes? Were they being monitored, or was there any difference?
Yes, they were being monitored. We did daily physical exams on every cow, looking at metritis as well, from days 1 through 10 postpartum. No difference. No difference between groups.
Okay. Excellent. Yeah, so the other thing then was on terms of the blood calcium meters. You and I have had this conversation before, and it's an ongoing conversation. So just for the audience sake, what are your take on calcium meters, the availability of calcium meters? You know, where do you just kind of see this space?
So at this point, if you want to take a cow-side measure of ionized calcium, your best bet is going to be an I-stat. And I recognize that it is cost prohibitive and a tremendous challenge. Cost prohibitive, not just even to get the machine, but each cartridge is quite expensive. Yeah, I mean, running it on these cows in the winter was extra fun. There's the one thing I'd add to that is I see quite a race in companies trying to create something that's a little bit more accessible for the farmer. And I'm not sure if it'll be an ionized calcium measure or a total calcium measure. I've seen people talk about it in urine and in blood. And I think that there's some great technologies getting ready to be released. But in terms of a gold standard, something that's going to give you something reliable and consistently reliable, I would recommend an I-stat. But again, I know that that's quite cost prohibitive. The only other option, again, would be to send a sample out to the lab, which I'm not sure if that's quite cumbersome in another direction as well. So I'm not sure if there's something great out there quite yet that can compete.
Yeah, and I think, Geneva, that's probably the same with a lot of technology, that we're kind of in the early days with a lot of this stuff. You know, we're very good at talking about the benefits of technology, but I think from a practical sense, to actually apply this stuff on farm to make it usable, we're still a few years away from a lot of this stuff, and a lot of things, not just in calcium meters. I think this is quite across the board with a lot of things. Okay. Yeah, so there was one other, there's a couple of other questions I have.
Mhm.
So one of the other ones was you mentioned trying to reduce the level of cations, and presumably you're talking about potassium there when you're talking about that. And one of the interesting points that you had there was the conversion of vitamin D to 25 hydroxy vitamin D, and that having an impact then on calcium absorption as well. So can you just speak to that a little bit in terms of, magnesium levels in the diets? Why are we looking to just basically summarize that whole picture of why we have that strategy?
So when you add, so the whole goal in adding, let me give you my answer and you let me know if I've answered the question you're actually asking. So the whole method or idea behind adding anions to the diet is that we're putting this cow in this compensated metabolic acidosis, and that acidifying the cow, that's not truly what we're doing, but we're going to use those terms just to keep it simple. The acidifying the cow is going to improve the sensitivity of some of those receptors to PTH signaling. So if we are adequately acidifying her, it also means that those calcium stores are more readily accessible to her and at the drop of a hat when she needs them most. If we start adding, or if we don't adequately restrict things like potassium, and I recognize this is a massive challenge, particularly when we talk about grazing cows, you're basically counteracting all of that good work you're doing by adding in an anion. And it's taking the whole calculation and just kind of turning it on its head, and she's no longer in that compensated state. So all that sensitivity you've built in those receptors is now suddenly not sensitive anymore, and you've kind of brought her back to zero, if that makes any sense. Magnesium plays a different role in it. Certainly it's a cation, but not a significant one we necessarily consider within the calculation. When we're talking about DCAD, magnesium is a really important component in terms of activating the receptor, in that you need it present in order for that receptor to operate functionally. I have somewhere a slide that illustrates something from Jeffrey Goff's work. Oh my goodness, Jesse Goff's work. Wow. Been a long day. Jesse Goff's work that's showing basically kind of a pictograph of that, in that you need that magnesium present, and then suddenly the receptor is available to the PTH and get that process started. So does that answer your question?
Yeah. No, it was just a general question around kind of what are the general ideas. And I know from having spent time or seeing your presentation and other presentations, actually the level of calcium, you're kind of increased the levels from what some other recommendations would be, and I believe getting up to even as far as 0.5% of the dry matter, 0.45 to 0.5% of the dry matter in magnesium.
Yeah.
Okay, so tell us a little bit about what you've seen on National Dairy Farm then, in terms of, what do you see as the kind of the key differences you're after coming from a really applied, really technical research side, to then to try and come to the kind of the real world, to with a lot more people working on it who are probably not as motivated to make things as successful maybe as what you would see. So just tell us a little bit about your experience today.
So, I have to say, I came into this acknowledging that this is a commercial farm, that there are greater goals than completion of my PhD dissertation at play here. And so I don't think I had, I don't think I necessarily, I actually really just expected to kind of fly under the radar and try to do the best I could with what I had. And I actually have to say that I have been extraordinarily impressed with the team at National Dairy. And Gerald, as you know, he is wonderful, and he's very humble about what the farm has to offer. But I disagree with him that I think that the things that they have achieved have been extraordinary, and I feel like quite demanding out there, asking them to collect all these samples and store them and do all these different things that I would expect of my research team on a research herd, and they have not just risen to the occasion, but far surpassed it. And so I'm actually quite impressed with all the work that's gone into it here. Yeah.
Excellent. Yeah, and I think some people on the call will be familiar with the video that we have done. Gerald has been a fantastic supporter of us and given us a lot of opportunities to trial. And this is kind of part of why we're having this conversation, even in Geneva, is because he's given us the ability to try new things. And, you know, he's the first farm in the Middle East to use the new concept of replacing all inorganic sources of trace minerals.
Mm-hmm.
And then trying to do is how can we pull some of the newest literature and combine it in conjunction with all technologies, and then actually see what happens when we do that. So I think, you know, the results really that we see on national dairy farms speak for themselves. We're less than fevers, less than 5% metritis, 8% ketosis, less than 5% RFMs, and a lot of that is because of the work that you have done and Tom Overton has done, and the work that we have taken and added our kind of all technology piece to it in terms of mineral supplementation and yeast and stuff like that. And then Gerald, obviously, on the management side and the way the cows are managed in that transition period. And so it's a kind of a success story for everyone involved. So that's been a lot of fun.
I mean, when we first met at the dairy short course in New York, and you were showing me some of the data that was coming out of it, I was already hooked at that point. And so I mean, you asked me about the farm, so I spoke a lot to Gerald, but I have to commend you as well, like the changes and the alterations you made. Yes, Gerald okayed them and is motivated to try new things. But I also commend you as well for really trusting the research that we're doing and that others are doing, and really applying it in a meaningful way. It gives us the opportunity. I mean, whatever we do in these tie stalls and on this research dairy, that's really great, but do you really know until you get out there and see it in action? And so thank you for letting me see it in action. It's been really exciting.
Thank you. And I think just one final one. Actually, can we go back to one of your slides? Because this will be an interesting one, actually. So the urine pH versus the DCAD on paper of those diets, and the level of anionic salts that had to be fed to reach it. Because again, it's the same with any literature, any research. You will have people who are pro one way and pro another way. And the only reason I'm pro this way is because we have tried many things on National Dairy Farm practically, and this seems to be what has worked the best for us. Could you just speak to those? Because I see, yeah, this is what I actually had noticed. We actually had a lower, more of a negative DCAD on the 0.7% calcium. So can you just speak to that a little bit, please?
Sure. So, I mean, so when we're analyzing the diet, I'm really glad you asked about this, because this is a little bit of a soapbox of mine, is when we analyze the diet and we do all these fancy math equations and we put in this very specific amount of your anionic supplementation, and we calculate the DCAD, analyze the diet, whatever, that spits out these numbers, which is, it's interesting, and it certainly I'm seeing differences. But if I looked at this and then compared it to another paper, Kristen Glosson over at Illinois or California, I'm looking at very different numbers, though theoretically maybe hitting some of the same urine pHs. So I'm a big believer in the cow will tell you where she is. I really pounded home on that compensated metabolic acidosis. And I say compensated because the reason you can measure your acidification based on pH is that she's compensating by dumping those protons in order to keep herself in balance. And so seeing the degree to which she's doing that in real time is really telling you, okay, this is sufficient to get her to a specific state, which will help the signaling. And that's what you're really trying to achieve. So I'm not saying that this number is useless. I am saying that in terms of comparing and really figuring out where your herd is, the urine pH is so key, and it's so simple to do. Unlike measuring calcium, it is very easy to measure urine pH. And since you've already got me on this track, I think it's important to note there's some really interesting work around urine ammonium, which I'm not sure is something that is quite ready for a more applied setting at this point, but I hope in the future it's going to get easier and easier. We did this in the lab, but again, it was just an M-color test, and really simple indicator of urine ammonium excretion. And that's important because groups like Constable, I think Drakeley just came out with a paper recently, maybe with Constable actually, looking at urine ammonium in terms of its ability to accurately portray where the cow is when you get past that urine pH of 6. So again, as part of that compensation mechanism, dumping urine ammonium is another way that the cow can keep herself in balance. And once she gets past a certain level of acidification, the more accurate indicator of where she is might actually in the future be ammonium, which is why I found it really interesting that, yes, we saw these, certainly the distinctions between groups and when we talk about DCAD, but calcium as an added cation, it's already starting to point towards this tendency where we see, oh, that added calcium cation really does actually start to make a difference in some of these treatments. So that was not necessarily the full point of the study, and I get made fun of for getting into the weeds with it a little bit, but I do think it's a really cool, speaking of technologies and diagnostics and things like that might be neat for the future.
Yeah, I agree with you. And I mean, at the end of the day, that's kind of the whole point of what we do, is to try and find areas that we can probably improve upon going forward. If there's any bit of fine tuning or just to get new ideas, I think it's kind of quite exciting. And can we just see the close-up rations there as well, please?
Sure.
Okay. Okay, so you had the same level. That's interesting to see that that even with the higher level of calcium carbonate, you didn't need to feed any more animate to get the response.
No.
Wow, that's interesting.
Yep. Yep.
Interesting. And I know you done this trial with animate. I mean, the reason behind my understanding, these commercial products and Soychlor, Biochlor, Animate, we use anion booster. They all seem to have similar effects, and it's really because they're very palatable, and that's what helps drive intake. I come across a lot of rations, actually. It's funny with ammonium chloride, and we can actually see intakes down as low as 10 kilos in the close-up period. So one of the strategies we have done, as you will know, on national dairy is we use a certain amount of the commercial product, but then we also use calcium chloride and magnesium sulfate as extra anions, and that also helps us get our magnesium levels up and also helps us get our calcium levels up. So we're doing 3 jobs with those 2 products, which is kind of
I love that. That's efficiency.
Excellent. I don't think I have any other questions for you, Geneva. I don't think I have anything else other than to thank you very much for your good work, and to Tom Overton as well, and the good work that he's doing, and all of the folks. Really, it's a credit to all of the universities in the US, do a really fantastic job, and universities around the world are doing a fantastic job. And I think the fun part for me is, as somebody who actually has boots on the ground, is taking this information and trying to apply it practically and then see what happens. That's really the fun part for me. Yeah. So thank you very much, Geneva.
Yeah, thank you very much. And please, you're welcome to share my contact information if there's future questions on this. So
excellent. All right, Geneva, thank you.
Thank you.
Bye-bye.
Bye.